Okay, so in this video I'm going to show you how to use a temperature sensor and a relay to turn on your fan when a certain temperature is detected in the room, and to turn off the fan when a certain temperature is detected in the room. So there's a small speaker in here that makes a noise every time it turns on. I'm just going to start by taking that little speaker out. Unfortunately, I can't disconnect the PCB board from the fan due to this bus cable here that won't come off the actual PCB. But here's the speaker right here. It's a small piezo speaker. So I'm just going to grab my needle nose pliers and try to take it off. There we go. So now when I turn on the fan, there's no noise. Okay, now I'm just going to reassemble the fan. So this is what a piezo speaker is. It's got a really small voice coil in it that vibrates a small piece of metal inside that makes a really high-pitched noise. Normally speakers don't have a polarity, but the piezo speaker does have a polarity, so you have to make sure that the small leg is in the negative and the large leg is in the positive. By adding different voltages, you actually get a different frequency from it. So the higher the voltage, the higher the frequency. And this is just a test run, so this would be the 3.3 volts here. And this is the 5 volts. So I'm going to be using an LM35 transistor as my temperature sensor. This is the relay I'll be using. It can run at 125 volts AC at 10 amps. The way the relay works is these two are normally open, these two are normally closed. So there's only electricity flowing through here when the switch is closed. Since we're using alternating current, there is no positive or negative, so it doesn't matter which one goes where. So this is my LM35. I have the base hooked up to the analog 0 pin, and I've got 5 volts running across it. Okay, so since the PCB has a momentary switch, the power needs to be pulsed in order to turn on. I'm going to bypass that by soldering a jumper cable to it. So in order to bypass it, I'm going to have to bypass this third pin here to this pin here. So I'm basically completing the circuit so that the switch doesn't have to do it. So I'm just going to start by fluxing these pins. Okay, so I have solder on the wire already. I'm just going to fuse them together. Okay, there's one. Okay, now I'm going to solder the 5 volts connection. And that's it. Okay, so I've programmed it so that when the temperature reaches above 24, the fan will turn on. So my room's usually about 21, 22. So if it gets about any hotter than that, then it's going to turn on. Okay, now that I'm finished with all the prototyping, I'm going to insert all the hardware into the fan, and I'm going to mount the battery onto the bottom so that I can replace them whenever I need to. Now I'm going to use a Dremel to cut away at these bottom plates here so I can mount the battery on the bottom instead of the inside, so I can switch them whenever I need to. Okay, so now I've got my power source into the base of the fan. Okay, so now I've got heat shrink on all my wires, and I'm going to shrink it with this hot air gun. So I cut out a hole where one of the screws was, and I mounted my temperature sensor on it so it sticks out the back of the fan instead of the front, so it's not affected by the air. So I soldered some female to male jumpers just so that I could clean up the job from the relay to the board itself. Okay, so everything's wired up now, it just needs the power source. Okay, so I just finished wiring the relay. I have it wired to the normally open gates, and I shortened the wiring here so it's nice and neat. Now I just have to put it back together. So this is what it looks like when it's finished. The temperature sensor's down here on the right side, and the power source is down here on the bottom. So when I heat up the temperature sensor with my finger, it should turn on the fan. And when it drops below 24 degrees, it should turn off by itself.